To the second part, discussing difference between IT and OT security. We're continuing with discussing system operation. So in the IT world, you have in your company, your university, you have a selection of standardized operating systems, Windows, Linux, Mac OS. You have an IT team that says you have to install Windows Enterprise Edition 64-bit, and they have their own way of managing upgrades or updates. They have if it's a company asset, they have a remote connection to it and they ensure that patching, upgrades, security updates can be applied in a kind of an automated manner. So there is support on behalf of the operating systems in the enterprise or server editions that they can apply patches throughout the enterprise to all the terminals, all the terminal computers, and this upgrade process is straightforward. And again, everyone will have an operating system recognized by and supported by IT. You have this Windows version, this Linux version, so this is how we maintain and ensure proper system operation. In the OT side, this is not the case. You don't have Windows and Linux on your controllers. You may have different and proprietary operating systems, even though we've been seeing more and more commercial off-the-shelf operating systems, more Linux, for example. Many HMIs are Windows-based. Still, since we're talking about an industry where controllers devices stay for many years, it's very probable that most of the systems will have different and proprietary operating systems. And many of them may not have security capabilities built in, and one of these capabilities could be the ability to remote connect and apply patches to it. So when we talk about an upgrade, when we talk about applying a patch, this cannot be done by the IT side of the company, right? It has to be in collaboration with the vendors, whoever designed the PLC, the controller, the operating system, the hardware. It has to be carefully made and in collaboration with the vendor. So you have to ensure you're under an appropriate contract with the vendor. The vendor is not out of business and they can still support and maintain the controllers you have in your system. And also the vendor can help ensure that your specialized control algorithms are not affected. So big difference in IT, you can apply across the board updates to all the terminal computers of your enterprise. In the OT, every controller from different vendors, even within the same vendor, you have to have a separate approach for it, and you have to also rely on the vendors for any software change that you have to do. So, and this is introducing, in a way, it increases the attack surface, right? Because if someone attacks the vendor or manages to impersonate the vendor, and the vendor has access to your system for updates, then you have a security problem coming from that supply chain channel. Supply chain attacks are actually very common because you attack a system by relying on the insecure approaches of third parties, right? So when you impersonate a vendor, you direct the human operator to a website and you say, well, you have to download this firmware, but this firmware is malicious. We saw the SolarWinds attack, right? The SolarWinds attack happened through a malicious update to the software. And the attackers managed to gain access to lots of systems through that malicious update. So in this case, in the OT side, because we rely a lot on vendors, we need to find proper ways of ensuring supply chain security. One of it can be firmware signing. Unfortunately, we've been seeing more vendors applying either digital certificates or other ways to ensure that the firmware is the right one and comes from the right location and the right vendor that has the key to properly sign the firmware, so it is guaranteed to be coming from the right source. And next, we'll discuss resource constraints, and that's also a very critical difference. In the IT side, our computers, the computer you have in front of you, right? What is the CPU you have? What is the memory you have? What I have here is my laptop. It's a 2.4 gigahertz processor. It has, I think, 64 gigabytes of memory. But these numbers are it's not what I need, but it is what I could need, right? If I have many programs running, may I do some browsing, I'm writing a paper, I'm watching a video. So regular computers have CPUs, have memories, mostly planning for a worst case scenario, right? What is the upper bound? How many programs can be supported in parallel? And because there is this kind of a buffer that you can, your processor is typically way faster than you need most of the time, it's not a problem to add, for example, an antivirus, right? Antivirus could be resource intensive. It could be taken out of CPU utilization or a lot of memory, but you can afford it. If you have 64 gigabytes of memory, you can give 1 gigabyte to the antivirus. This is definitely not the case in OT. The PLCs we've been seeing, and even though this is changing, right? But again, PLCs, controllers are staying for many years. They were designed to support something very specific, and that's an industrial process. So the memory ranges we see would not exceed 256 megabytes. And the processor we see, the frequency wouldn't exceed, say, 500 or 600 megahertz. So we've been doing some research on PLCs, and these are the typical CPU frequencies and memories we see. And this is more than enough for controlling the process, because what the PLC does essentially is reading values from the input, doing some control operation, and then actuating, right? And there's no graphical interface. So it shouldn't need a big CPU, it shouldn't need much memory to achieve those things. That's why they're designed to support the processes, and we don't see fast CPUs. They don't need them. So the problem with that is the PLC is designed to do that thing, and you cannot add extra things to that. You cannot add antivirus on it. You cannot add an intrusion detection solution, because it doesn't have enough memory, and will start now violating, as we saw before, the real-time requirements, because it may be trying to scan the file system, and at the same time is trying to respond to the process, and there could be some resource contention in that. So the practice of adding malware detection on the controller is not easy to do in OT. So you have to think again of other solutions. Again, solutions could be proper network segmentation, DMZ zones, and other things we'll see later in this class. Another difference is communications and the protocols used in the IT world and the OT world, right? In the IT, we're very familiar with TCP/IP. There's also UDP, and that's about it, right? And the medium, the physical layer, we have Wi-Fi, we have Ethernet, Bluetooth maybe, but these are all very standardized, and every device we have uses them. So it's either wired or wireless, and the networking practices can be pretty standard, right? You have your firewall opening your TCP ports, UDP ports, standard services, we have HTTP, FTP, SSH. So there are typical IT networking practices that can be followed for good cybersecurity. In the OT side, you have proprietary, and sometimes you have standard communication protocols too, but many of them are proprietary, so you don't know exactly how they work. So you can add a security mechanism to them. And communication, in the IT side, we'll communicate locally through our wireless in the house or Bluetooth with our personal devices, and far away communication happens through the internet, and that's about it. In the OT side, the internet may or may not be used, and when we talk about telemetry and distance communication, you have several types of communication media, from either dedicated wire, you have your own wire, your own cables, underground or overground cables to connect to your field station, or you may have wireless, like radio frequencies or satellite. So all these things, they introduce their own complexity and their own security challenges. Proprietary is a problem. Different communication media is a problem because we have to think of potential attacks on each side, right? We've seen attacks through radio frequency because that's something everybody can send radio signals, right? So if you do radio frequency communication, you have to ensure that there's no jamming or there's no man-in-the-middle attacks that can be performed by adversaries. So in the OT side, deep packet inspection, on Modbus may not be straightforward, or on DNP3. Firewalls may also be, you have to have rules for the industrial protocols when we're discussing OT communication. So there's a big difference between the two, mostly stemming from the fact that the OT side, we have, again, concluding proprietary protocols and several types of communication media. So the complexity of the networks, when you want to find cybersecurity solutions, again, it cannot be a security engineer one-man show. You have to discuss with the control engineers to ensure that you're adding maybe delays in the communication link, you're adding redundancy, you're resending messages for integrity, you're adding checksums, you're adding certificates. This adds delay. Is it supported? So you have to be in constant communication with your control engineer to ensure the appropriate methodology for securing communications in the OT systems. The next item to discuss is how is change managed, change management. In the IT world, software changes are applied in a timely fashion. Let's say every Tuesday, you apply security patches in Windows, and you have your own security policies and procedures, and you don't even have to worry about them. The procedures are automated. So every week, your system is updating itself or updating the terminals of your enterprise to ensure that you have the latest version of the operating system and the right security patches applied. In the OT side, you cannot just automate this process. Because again, patching could mean that you have to take the controller offline. So you have to plan maybe weeks or months in advance to do that. And you also have to ensure before applying anything, before you change anything, you have to thoroughly test that the change is not affecting the process. You have, and if you are to apply changes to many devices, you may have to incrementally do it, apply one change to one device, install it, see that everything works fine, and then install the next one. So you cannot be massively doing changes throughout your process controllers and see what happens. So, and this is a big problem. You cannot automate it. You have to test it very exhaustively. You have to do it incrementally. And if it's causing an outage, you have to plan days or weeks in advance. So this cannot happen, of course, with the frequency of weekly or daily updates, right, that we see in the IT. But they cannot be happening never. Or cannot be happening every 5 or 10 years. There's an appropriate balance to be found that I'm applying a patch. Again, that goes back to risk management. I am applying the patches every 2 months. I'm applying patches every 6 months. If there's a vulnerability that I haven't patched, maybe I increase I change the notch on other security controls. I'm very careful because I know there's something that could be exploiting the system, so I'm aware of that. I'm not applying the patch yet because the next plant maintenance is 3 months from now. So an appropriate security practice would be to be aware of the vulnerability and before the patch is applied to ensure that there's no way that the vulnerability can be exploited in the meantime before it's being patched. But this takes very careful planning, and it needs kind of a daily, it's a daily process that the security team of the company has to be doing to ensure that there's no window of opportunity for the attackers to exploit. And another thing here is that the ICS, the systems, the control systems may use operating systems that are no longer supported. Microsoft, for example, they ended support for Windows XP a few years ago. So if you have Windows XP machine, you cannot rely on Microsoft to be updating, to be giving out patches for security vulnerabilities. So you either choose to update the systems or you choose to do your own maintenance or find some other way of ensuring proper security in those systems. Next is managed support. So in the IT side, you have your computers. Let's say it's an enterprise that is administering the enterprise computers. You have your Windows, your Linux, Mac OS machines, and then IT makes a decision that I'm going to install antivirus on everyone, so they install an antivirus. And then IT makes a decision, everybody has to have this remote access system for us to be controlling the devices to ensure there are no problems and to be applying patches. And the IT can do that. Then the IT says, okay, there's phishing attacks. We're going to apply to all the email servers a specific email phishing solution to ensure that the employees don't click on emails and they don't install malware accidentally in their computers. So the IT side has a lot of options for support, diversified support styles, and the systems may be different, right? They're connected, but they're different, but the IT can definitely manage that. In the OT side, the landscape is very different. You may have support by a single vendor, or you may have support from different vendors. You have, vendor one in this substation, vendor two in another substation, or multiple vendors in the same substation. And when you discuss security, every vendor will say, well, I cannot apply those mechanisms because there's another vendor machine connected to that, so this is not my problem or my fault. I cannot give you guarantees. So you may be locked in using one vendor, which comes with its own problems. Lack of diversity, that if there's a problem in one device, it may be easily found in other devices of the same vendor. And another thing, if you say, okay, I'm going to add this security solution to the controller, the vendor may respond saying, well, then you lose your warranty. We have a service agreement. I'll be doing all the patching. You cannot apply anything. If you do that, you're losing the license. We don't maintain that. We don't support this device anymore. So you're kind of locked out of applying security solutions that you think are appropriate for this. In the IT world, you can apply solutions that you think are appropriate, your own malware detection system, your own phishing detection. In the OT side, you have to connect to the vendor, and if you have multiple vendors, this can become a very complicated problem. Next, component lifetime allocation. The IT side are computers, devices. Their lifetime is not expected to be more than 5 years. Technology moves fast. A computer that's fast today may not be fast in 5 years from now. And if you want to change your computer, you go to Best Buy, or your IT will procure a computer for you from vendors and will give them to you. So that's a more streamlined process because we're talking about commercial electronics. In the OT side, when you install something, you expect it to run for many, many years. The slide here says 10 to 15, but it's not that common to see 20 or 30 years of a lifetime of deployed technology. The components may not be close to you. You may have a remote substation, so you may not be able to easily access and change them. You may have to drive. That you're losing. You need time to access. And if you do that, then the attackers have this knowledge, and this downtime that you have to physically go somewhere and get access to, in order to have physical access to your device, it has to be included in your risk management in understanding what security controls you need for remote, for field stations. Also, replacing something if there's an attack and your firmware has been overwritten by an attacker, and now the device is fully destroyed, it's bricked, you cannot recover. You cannot just go to Best Buy and get a new serial to Ethernet modem. You have to procure it through the proper channels. This process takes time, and this affects the downtime of your process. You cannot wait for months to recover your substation. You have to have, of course, a solution will be backup controllers, or to have redundant ones waiting. If something goes wrong, you replace them. But of course, when you replace your Ethernet controller, if it's the same one, there's a possibility that the attacker is still in the network, and they will overwrite the firmware again and render your new modem also uncontrollable, and they may break it and they may damage it beyond repair. So all these things have to be included in risk management when we talk about OT security.